Hello, guys. It's Mr. Goals. How's my grade fives doing? I decided to do a little bit of different lesson for you in terms of volume, capacity, and displacement because it can get a little bit confusing. And I kind of saw some of your answers, and I want at least some of you to kind of go back, fix up certain things. But I decided to kind of do it orally, so maybe some of this can actually help you understand a little bit better about volume, capacity, and displacement. Okay, so first and foremost, there's a picture on the left-hand side of the screen, and this is capacity and volume. The first jug of water says that there is a jug of water that has a capacity of 250 mils. All right, that means that that actual container can hold 250 mils. That is its capacity. Now, the picture in the middle shows volume, and it shows that the volume of liquid in that container is 125 mils. So volume is a little bit different than capacity. Now, volume and capacity can be the same, but in this case, it is not. The volume is the space a material can hold in an object. So in this case, the material is water. And in this case, it's only 125 mils. That is its volume. Okay, so there are similarities, but there are differences as well. Okay, next screen. Volume and capacity. Now, I've orally explained it to you. See if you guys can put it in your own words to explain. All right, it's good practice as you get older to understand how these things matter, especially in science, as well as math as well. All right, displacement is a little bit different. And now you're probably going to ask me, why, Mr. Goals, why did you put a guy in a bathtub? This is Archimedes. Now, I'm not going to explain too much of Archimedes, but if you look at the bottom, it says the volume of Archimedes equals the volume of water displaces. He's the guy who came up with the idea of displacement and volume. He was trying to prove something for a king 3,000 years ago, and he figured it out, and the very famous word eureka came about. So if you're bored in the next month or so, you can Google him, and you can figure out who Archimedes is, but he's known for the displacement theory. Question 2, conversion. Okay, before we move on to displacement, volume, and capacity, and those questions we have to do, you have to convert. Now, the easiest one to know is 1,000 milliliters equals 1 liter. But you also have to understand that volume can be either in liters, milliliters, or anything representing kind of liquids that we're familiar with, but it could also represent 3D, which means things like centimeters cubed and meters cubed. So think about you buy a pair of shoes and they come with a rectangular prism. The volume of that rectangular prism is measured in centimeters cubed, right? So don't forget that. Capacity, on the other hand, is usually in terms of liters or milliliters, okay? It's important to note that centimeters equal milliliters, or more particular, centimeters cubed equals milliliters, and meters cubed equals liters, okay? Next screen, displacement. So we kind of mentioned a little of displacement before, but here's the real idea of displacement, okay? If you have a glass of water and it has a water level and you put in ice or lots of ice, the water level increases. Obvious, right? Yeah, when water levels increases, you can get massive floods. And that's not a good thing, all right? But that's the idea, that you know that when something like this happens, water levels increases. Now, displacement and volume. For the most part, it's important for the most part, not all the time, but for the most part, volume equals the water or the amount displaced. So if you have a glass of water and it's 50 mils, and you put one big piece of ice, the water level can increase to 75 milliliters. That means that the amount displaced was 25 milliliters, which is exactly the block of ice and its volume, which is also 25 milliliters. That's kind of what Archimedes came up with. So again, just to recap, the water level is 50, you put in one big piece of ice, the water level increases to 75 mils, you subtract the two, you figure out that the volume of that block of ice is 25 mils, and it's also the same amount of water that's being displaced. Okay, questions 4, 5, and 6. Yes, question 3 is sleeping. It went bye-bye. Question 4 is displacement. So water level was 60 mils. You put in 3 marbles. The water level increased to 90 milliliters. what they're asking for is what is the volume of each marble. But if you know that the water level increased from 60 to 90, you know that all three marbles have a volume of 30. And what the question is asking, well, how much would each marble be? In other words, what would be the volume of one marble? Okay. Question 5 is hard, and I'm wondering if you guys can figure this out, but maybe my explanation can kind of lead you to it. There are two shapes. They're identical in size and shape, but the one built with wooden cubes is heavier. Would the two shapes displace the same amount of water? I don't want you to think about volume. Okay? I want you to think about just common sense, the idea of weight. Okay, so if one weighed more and you dumped it in water, would the water level increase the same or less if one weighed more than the other? I'll leave it at that. Okay. Question 6. Question 6 is a lot like question 4, so I'm not going to spend too much time on it. But again, read it very carefully. It's asking for the volume and the displacement of the pyramid, as well as the total amount of water displaced by the three marbles in the pyramid. The original water level was 125, and after you put in those four materials, the water level reached 195 milliliters. Why is there a pyramid there with an eye? The Illuminati may be watching you. And don't ask me who the Illuminati is, okay? Last question, is the cow, the milk, and Mr. G? You can do it OLS. Question, or next slide. Look at the fridge, but no pizza for you. There is a milk carton that you have to create. You don't actually have to create a milk carton. I just thought if you wanted to, go for it. But the milk carton has to fit in the side door of the fridge. But if you look at it, the side length is 50 centimeters, the height is 50 centimeters, and the width is 10 centimeters. All right. You need to fit a 4-liter milk carton in that door with those 3 bottles right there. So you need to think what the dimensions of your milk carton will be. Okay, continue, but don't eat my pizza. But remember, liters and centimeters don't work. But what do work is centimeter cubed and milliliters. So you have to convert your liters to milliliters. That's going to help you find the right dimensions. Okay, so remember, 4,000 milliliters equals 4 liters. Now you need to find the proper dimensions. Remember, volume, length times width times height, that will equal to give you 4,000 milliliters. But your length can't be more than 50, your width can't be more than 10, and your height can't be more than 50. Why is there a picture from a guy from the Matrix? When you're in grade 8, and if I'm around, I will definitely help you understand. You have to understand most of these people are not ready to be unplugged, and many of them are so injured, so hopelessly dependent on the system that they will fight to protect it. Last but not least, you still can't get the pizza because it's mine. Listen up. I hope this helped a little bit. Take your time with your answers. Real sentences, please. And if you need to email me or contact me, please just do it. Mr. Goals signing out on a Wednesday afternoon. Peace.